Hi everyone, my name is Matt Timmons Brown. Some of you may know me as the Raspberry Pi guy, and I'm super happy to be here with you all at the Virtual Pi Wars conference. Of course, I wish we could all be in person in Cambridge. It's actually my local city, but this pre-recorded video from my student flat up here in Edinburgh will have to do. So today I'm going to be talking to you about robotics at university and beyond. I'm going to try to give you a student's perspective about what comes next after taking part in an event like Pi Wars and being interested in hobbyist robotics, and how do you get to the next step, working with robotic arms, working on cool things that, for example, you see like companies such as Boston Dynamics doing. So this is what my talk is going to be about today. Before I get started though, let me just tell you a little bit about myself. So as I said, my name is Matt, and some of you may know me as the Raspberry Pi guy. I've been passionate about Raspberry Pi and all things computer science since I was 12 years old back in 2012. So that's almost a decade ago now. I'm 21 years old. That's when the original Raspberry Pi came out. So it seems crazy that the Raspberry Pi is almost a decade old. And in fact, that was actually the thing that triggered my interest in computer science. So when the Pi came out, that's how I got interested in computer science, and sort of everything I've done has sort of stemmed from that. Back in 2012, I launched the Raspberry Pi Guy YouTube channel as well. So that's a YouTube channel that maybe some of you are subscribers of, hopefully. It's dedicated to providing computer science tutorials and videos based around the Raspberry Pi. Over the years, it's racked up 6 million views. I don't keep it super up to date anymore, just because I've been super busy with some of the stuff that we're going to talk about in my talk today, actually. But not formally retired just yet, but that's my YouTube channel. And then actually more recently, in 2019, I also became the author of a book that's very relevant for something like today. It's called Learn Robotics with Raspberry Pi. And this is a book for beginners and intermediate hobbyists, much like I imagine a lot of you are, on building robots with Raspberry Pi. So actually the book is project-based. It takes a reader through building their very first robot from start to finish, making a robot chassis, remote controlling a robot, adding sensors, computer vision. And this is actually quite a popular resource nowadays for robotics hobbyists over the last few years, and it's available on Amazon and everywhere else. More about that at the end of the presentation. So those are my Raspberry Pi credentials. What about some of the other stuff that I've been up to? So most notably, I'm now a third-year undergraduate at the University of Edinburgh, studying computer science. I'm studying for my BSc in computer science. So I'm a penultimate year. And you can see Edinburgh down on the right-hand side here. So it's a very, very beautiful city. If you haven't been, I'd recommend you visit. Excellent university and really a top-notch computer science faculty. I'm extremely happy up here. So this is what I'm doing full-time, a full-time computer science student. I'm also alongside this a robotics research intern at the Edinburgh Centre for Robotics. So this is me up on the right-hand side. So the Edinburgh Centre for Robotics is one of the university's robotics laboratories. It's actually run by Professor Sethu Vijayakumar, who some of you may know from BBC's recent Robot Wars reboot. He was one of the judges on that. And so the Edinburgh Centre for Robotics performs robotics research. And so I intern alongside my studies. I actually work on this platform down here on the left-hand side. This is the next stage dual arm humanoid robot, sorry. And we have quite a few of these. And so I work on adding capabilities and all sorts of that to that platform in particular. For example, these hands that we can see sort of scheming, the robot looks like it's scheming down there. There's some stuff that I've been working on adding to that robot and some of the functionality that I've been incorporating. Now, previously, I've also been an intern at Amazon Robotics. So I did that just in the summer just gone. So Amazon is obviously a huge company that has a lot of robots, has 200,000 of these little orange guys that move around goods around their warehouses and ensure that you get your products with Prime delivery, for example. So I interned with them over the summer. And previously, I've also interned with Huawei, less robotics. This was in 2019, but that was a tech internship in China. And actually this coming summer in 2021, I'm going to be interning at a company called Arrival. They're an electric vehicle startup. They're using a lot of robotics to build electric vans and buses in sort of a brand new way. So this is a really exciting startup. So there's sort of some of my robotics and my academic credentials. And yeah, that's more info about all of this over the next few slides. So let's get started, back to the talk. So what is this talk actually going to be about? In this talk, what I'd like to do is discuss my thoughts, experiences, and perspectives on the jump from hobbyist robots, like a lot of the robots that some of you have made or even are in the Pi Wars competition, for example, to some of the robots that we see in research and industry. So for example, like the Spot robot, this robotic dog, it's called a quadruped, from Boston Dynamics that we see on the right-hand side here dancing. Now, the robot on the left is actually the one that I show readers how to make in my book. So this is a very classic Raspberry Pi / Arduino type robot. It's really neat and functional. It can move around the floor, follow lines, sense colored objects, for example, but it's not quite a robotic dog, is it? So clearly the capabilities of robots from companies like Boston Dynamics, and for example, ones that are developed in the research that happens in my lab at university, are much more advanced than hobbyist robots, like the ones that you make with Raspberry Pi, for example, or that sort of stuff. Now, obviously that is the case. You'd hope that there was a cutting edge, which of course there is. But the question that I want to address in this talk is, how do you make this jump and go from sort of working on hobbyist robotics to working on something like Spot or Atlas, another one of Boston Dynamics' really cool robots? Now, this is a question that I'm, of course, navigating myself right now as a student. I'm by no means an expert. And so what I want to do is I want to actually share my students' perspective on this as someone in the midst of trying to work on cool robots and fashion a career out of this sort of stuff. A few years ago, I'd only ever played with hobbyist robots, like the one that I just talked about. And now I've had a few experiences that I feel lucky to have had, and I'd like to share that with you. And hopefully it goes without saying that, of course, these are all my own opinions and my own musings, not those of my university, my lab, or any previous employers. These are just my perspectives on being a student and trying to get involved in robotics. So just briefly, the contents of my talk are going to be an overview of sort of what you know as a current hobbyist, why you should pursue robotics further, and some ideas for how to pursue robotics further. So whether that's at university, through internships, and maybe after university as well. And I'm just going to finish that up with some sort of thoughts and advice for students and for other people as well. But of course, this isn't just restricted to young people. There are some, hopefully there's information here for everybody. So let's start with the base level, where I would say most people are at when they take part in an event like Pi Wars, or they're playing around with Raspberry Pi. Now that's hobbyist robotics. Now, a lot of people mess around with robots like the one that, as I said, made in my book, and these are great. They teach basic robotic concepts. They teach programming basics. They usually based a lot around like wheeled and tracked movement, tends to be sort of on flat ground. They teach a lot of electronics knowledge, some sort of control theory, some stuff about basic sensors, and a huge amount more. You can learn a huge quantity of information just by playing around with hobbyist robotics. So for example, you can take a very basic robot and you can give it some really intelligent behaviors like following lines, as you can see in this photo, or as I said, detecting colors and things like that. And these are some really neat things that you can do just with hobbyist robotics. But as I was saying before, as I alluded to before with the Boston Dynamics Spot demo of that robot dancing, those hobbyist robots tend to look quite different from the robotic arms and humanoids and quadrupeds that we see at the cutting edge of robotics. So just to go through some of the images that we have here. So on the left, we have the Spot robot that you saw previously. This is Atlas. It's also from Boston Dynamics. It's a humanoid robot that has been doing some backflips, and maybe you've seen some cool videos going around online. Up here in this right, this sort of montage of robots are some of the robotic platforms that are worked on in the robotics lab that I'm a member of. So most notably, you have the NASA Valkyrie robot, which is a humanoid robot that potentially will help humans build the next Mars base. We also have robotic arms. We have some underwater robotics, prosthetic robotic hands and things like that. So these are some really interesting cutting edge robotics research that goes on at Edinburgh. And then in the bottom right, we have a large robotic arm, industrial robotic arm, that's being used to move around goods in Amazon warehouses. So you can see that these are quite different from hobbyist robots, and I think they're really exciting. So it's a really interesting area with some of the world's most interesting problems, I think, at the moment. So for example, some of the problems are, how do we get robots to move like humans? How do we get robots to move like we do? How do we get them to adapt like humans do? How do we get them to process information, sense the environment that they're in better? And how do we get them to sort of accomplish certain tasks? If you think it, us as humans, or a dog, for example, they can perform really amazing behavior just without even realizing that. Something as simple as keeping your balance as a human is something that we do with absolutely no effort. But actually in robotics, that can be quite a hard problem. So a lot of work is going into these areas, and it's actually quite a relatively young field with a lot of work to do. This is sort of my pitch about why you should be interested in robotics. So what then? How do you go from hobbyist robotics to some of that stuff that I just spoke about? Now, the first thing to note is that robotics is an advanced field, of course, that involves many other disciplines and prerequisite knowledge. So most notably, it involves considerable amounts of maths. So for example, lots of linear algebra, differential equations, geometry, trigonometry, and all sorts. It requires a lot of computer science, knowledge of algorithms, control theory, software engineering to write code for robots. And there's a fair bit of physics in there, because of course robots are physical things that interact with their environment. So they undergo forces, their joints are exerting forces on the outside world. There's a large degree of mechanical engineering on how to actually build these robots, the physical design of them, and a lot of electrical engineering as well about the motors inside them, the sensors, the cameras, which form their vision. And so these are some very advanced fields that all sort of go together to create like a meta field that is robotics. So you have all of these sub-disciplines that are super important, of course. Now, other fields around robotics are quite similar, and these are fields that join very much so with robotics. So of course we have machine learning and artificial intelligence. Well, that's of great interest to roboticists because we want to give our robots intelligent behaviors. And obviously that requires a lot of mathematical knowledge and a lot of computer science knowledge as well. Other fields include computer vision, which is the science of sort of understanding the world through sensors and through cameras and things like that. And that requires a lot of these prerequisite knowledge that I've spoken about. Now, where is the natural place to learn all of this? Of course, it's university. So it's not impossible to do outside of university, but in my experience, most people in the field of robotics are highly educated with university degrees, bachelor's, master's, PhDs often as well. We'll talk about that a little bit later. But definitely an undergraduate degree, so a bachelor's degree, from my experience, is pretty much a necessity in the field of robotics. So assuming you now know you want to go to university, what should you study? So there are various paths at university, and we're going to go through some of them on the next page, and we'll go through some of the different options. But for any of you that are actually sort of currently going through the university application process, or you're picking your A-levels or your GCSEs, for example, usually what you want to go for are STEM-related subjects. So that's science, technology, engineering, and maths. Because all of the fields that I'm about to talk about and all of the degrees, these are highly technical degrees that require maths, computer science, and physics. So for example, if you're in England and you're picking your 3 A levels, do something like maths, computer science, and physics. And these ensure that you have the best possible chance of getting into the best possible degree at the best possible university, of course. So the University of Oxford, for example, they have some strong robotics research. Edinburgh is also a competitive university to get into. So if you have the right sort of subjects, especially for those younger of you, and you're interested in robotics, or you're thinking about what you want to do, definitely be picking those technical A-levels or their equivalent if you're in Scotland or somewhere else, of course. So assuming that you have the necessary grades and those sorts of subjects behind you, what are sort of your options at university? Now, in my experience, that there are 4 main routes to sort of pursue robotics traditionally. And this is by no means comprehensive. I'm sure there are many people in robotics who I'm sure have got to where they are through different routes, but this seems to be the most traditional way. So most notably, we have computer science, which is of course what I study. So in computer science, in a computer science degree, you learn a wide range of software and some hardware skills. So you learn a lot about maths. In my first 2 years at university, I had maths courses every semester in linear algebra, calculus, in statistics, and all sorts. So maths is a very, very strong component of a computer science degree. A large component as well is algorithms. So just understanding how to how to use computers to essentially accomplish tasks and problems. So whether that's searching for things, whether that's planning paths, understanding a lot about efficiency of how well computers compute things and the speeds at which they do that. So a lot of algorithms knowledge, definitely taught it early on in a computer science degree. And then throughout a computer science degree, you get a strong amount of software development, learning how to code, everything from object-oriented coding to functional programming to low-level programming. So this really serves you well in robotics, because robots are run by computers that are running code, as you all know, if you're competing in Pi Wars or anything like that. So those sort of three things are sort of the core of a computer science degree. But also we have, usually in the later years when you come to your dissertation and things, you have some robotics introduction courses and stuff like that. We also have some related courses in machine learning, artificial intelligence, computer vision. This is all some really good stuff in a computer science degree. Now, in the other degrees, of course, I don't study those. So I'm speaking from sort of the perspective of my friends and people that I know and people that I know in the robotics field that have done these. So of course you have electrical engineering, you learn a lot of the same maths, but focus of course on the electrical side of things. So you have electronics, digital design and logic, analog electronics, learning about sensors, usually do a little bit of software development, but definitely probably not as much as computer science. But it's quite interesting. You can potentially mix that with a computer science degree. So a lot of universities nowadays offer computer science and electrical engineering, and that could be quite an interesting combination. You also have mechanical engineering, as we spoke about. That's much more physical, to do with the physical design of robots. If you're more interested in sort of 3D modeling, CAD design and stuff, you're going to learn a lot of the same maths, but if you want to design the materials that robots are made out of, or how they look and how they perform, then mechanical engineering is a definite option. And you could also potentially mix that, probably more likely with an electrical engineering degree than a computer science degree, but you can definitely, maybe at some universities, you can pick a joint honors degree. And finally, there are some specialist undergraduate courses that I thought that I'd mention. Sometimes these can be called like a bachelor's in robotics, for example. And these tend to be mainly computer science degrees, but with more compulsory robotics topics, including computer vision and kinematics and things like that. But they tend to generally be most of a computer science degree. So usually studying computer science, just plain computer science at university is what a lot of roboticists do. So you're at university, now what? You're studying for your degree in computer science, and you may be getting some robotics exposure through some of your courses, perhaps later on in your degree. What else can you do? So one of the coolest things is that, fortunately, universities are some of the main institutions that perform robotics research. For example, Edinburgh has one of the largest robotics labs, and other places like Oxford and Bristol and lots of universities around the UK and around the world have strong robotic research interests. Actually, a university's specialisms in research could be a deciding factor when you apply to university if you're around that sort of age. So usually the research at university and sort of academic research is undertaken by master's students and PhD students and professors, but that doesn't mean that there's no opportunities for undergraduates. As an undergraduate, you can get involved in robotics. As I said, I'm an intern, sort of an undergraduate intern in our robotics laboratory at the university, where I work alongside PhDs and postdoctoral researchers and professors at the university. And it's possible to get involved on an internship / student basis. It's something I've been very fortunate to do, and I'm very grateful to Edinburgh for giving me this opportunity. But how do you get those opportunities? So one of the main things I'd recommend is to reach out to professors and academics to see if they need any sort of assistance in their labs or work. Say you're a really good 3D CAD modeler, you could offer some of your skills in 3D CAD to help out a professor or a researcher who needs some assistance in this. Or say that you know how to program in Python, for example, that this could be really beneficial to take to do some of the work that needs doing and get involved in robotics in this way. So definitely reach out, send a cold email to a professor, see if they have any time for you. It doesn't hurt. I'd also recommend befriending staff running your courses at the university. The professors that teach you at university are also the same professors and academics that run the labs that perform this research. So definitely being friendly with the people like this is something that's very, very worthwhile. So also look out for specific opportunities for undergraduates. Perhaps you can work on robotics in your dissertation when it comes to the end of your degree. Perhaps there's summer work, summer internships, or summer programs where you can get involved in some research or something like that. And also finally, I was talking about programs to get a taste of research. You even have possibilities like going on exchange. Now, in fact, I was actually meant to go to the University of Pennsylvania, where they have a really cool robotics faculty there, robotics research work that I was really hoping to get involved with. I meant to be in America right now. Unfortunately, COVID has happened, so that's been cancelled. But just so you know, that some universities have some really neat exchange programs where you can go to some really cool universities, like a Ivy League university, like University of Pennsylvania, or maybe MIT or Caltech or something like that. This is some of the opportunities available to you at university. Now, the other main way of getting sort of robotics exposure and experience is through internships. So these tend to be paid summer work for companies, usually go on for about 3 to 5 months. And you can do them all throughout your degree, even before your degree, but usually they're for undergraduates. And so robotics is a rapidly evolving space. There are more and more companies offering internships in robotics. So robotics interns or software engineering interns, but with a special focus on robotics. And there are fortunately loads of internships for computer science students. Sometimes you have to jump through a few hoops, and for example, you have to do some like coding tests to get them, but it's definitely worthwhile. So as I said, I interned at Amazon Robotics over the summer, where I worked with these robots that you can see moving around products in their warehouses. In actual fact, I worked on a computer vision / machine learning proof of concept project, and that sort of just shows you how related those adjacent fields are that I spoke about at the start. Computer vision, machine learning, and robotics, they're all very much interwoven in industry. So how do you get an internship? You just have to sort of apply. You have to shotgun your CV pretty much everywhere. So I've just included 4 examples of places that are actively hiring sort of robotics interns. So Amazon Robotics, of course, Ocado, the online supermarket, they have a lot of robotics operations. In actual fact, their warehouses where they have food rather than product like Amazon, they're all robotic. So they have a lot of pretty interesting robotic internships. I haven't worked there, so I can't speak about it too much myself. But then other companies such as like NVIDIA and Unity, these tend to be sort of companies involved in graphics, but robotics is very much connected with this in terms of things like simulation and computer games. A lot of the same theory of computer games applies very much to robotics as well. So it's just a really interesting opportunities at other companies that you can sink your teeth into, maybe as an undergraduate. Now, after undergraduate, what happens? You want to break into the industry or something like that. Now, for me, this is uncharted territory, of course, because I'm still an undergraduate student. But from my experience, there are many options. One of the main ones is further education. So a large proportion of people interested in robotics undertake masters and or PhD degrees. Usually, I've seen a lot of people up to all the way up to PhD. Obviously, as I said, robotics is such an advanced field. Having a high degree like this is really, really beneficial. So you could go directly into industry, for example, but if you want to be involved in the research and the development of robotics, and you want to be on the cutting edge, discovering new things and doing really novel new work, it usually tends to require the former. So it tends to require the fact that you maybe need a master's degree or a PhD degree if you want to go into industry straight away. Also, for example, by the way, this is the University of Oxford's PhD program in robotics, for example. Also, another option is you can get involved in just software engineering, but for robotics. So usually you're going to be implementing the research that those PhDs have done, but there's a lot of work to be done on the ground of actually software engineering these robots. And so you can just be a software engineer in this field, similar with sort of the mechanical engineers and the other degrees that we're speaking about. Or if you fancy it, you can start up your own company. You have a robotics startup. This is a big developing space. As I said, the company that I'm going to be working for over the summer is called Arrival, and they're building electric vehicles, specifically using these micro factories, they're called, to use robots to build these vans and these electric vehicles. So there's lots of different options and paths of doing stuff in industry with robotics. So this sort of concludes my very brief talk. Thank you for listening, and please, I hope you enjoyed it. My contact details are about to come up on the screen. So sort of in general, super exciting area of computer science, developing field, lots of interesting novel work going on, more and more opportunities to commercialize the work in robotics and actually make money out of robots. We're seeing more and more startups and more companies using robots, and lots of avenues to explore for a really exciting future career. So, but if you're still at the hobbyist stage, as I said, necessary book plug, if you want to have a look at my book, Learn Robotics with Raspberry Pi, you can access that at that link. That will take you to Amazon. It's got almost 100 5-star reviews. And it's a great way of sort of sinking your teeth into some of these early lessons in robotics. So please take a look. So thank you so much for listening to me. As I said, my name is Matt Timmons Brown. You can reach me on Twitter at Raspberry Pi Guy 1, via email or on LinkedIn. Not sure exactly how the conference is working at the moment, so I hope that we can chat virtually, and I really hope that you've enjoyed this talk. Feel free to check out my YouTube channel and everything else as well. Thank you so much, and I hope that you enjoy your adventures in robotics if this is what you choose to study and do your career in.